So let us continue from last class. We have studied hydrogen molecule ion. We couldn't finish the full derivation, but we have found out the value of A modulus square, and we have written the ground state energy of hydrogen atom. Eigenvalue equation, the eigenvalue equation of a normal hydrogen atom in the ground state. We have written that, and it is having the eigenvalue E1 is equal to minus 13.6 eV, which is equation number 10. So now we need to find the expectation value of Hamiltonian in this hydrogen molecule ion in the state psi. So we have taken the trial wave function psi. So let us find its eigenvalue equation for this hydrogen molecule ion. Before that, we have written here in equation in the hydrogen atom eigenvalue equation, we have written the eigenvalue E1, which is minus 13.6 electron volt, isn't it? So in this case, the proton and the electron in this hydrogen atom is at distance r1. If the hydrogen in the hydrogen atom, if the proton and electron are situated at a distance r2, then also it is the same. The energy E1 will be the same. So it depends. It does not depends on the value of r1. So it is the same. It is the same for, that is why it is written. This is the same if you replace r1 by r2. So R1 and R2 are not much different. So if you are replacing R1 by R2, then also this E1 will be same, which is minus 13.6 electron volt. Okay, so now let us write the eigenvalue equation of hydrogen molecule ion, which contains 2 protons and 1 electron. So we need to write the write in the state which is the trial wave function psi. So H psi is equal to, we know that it contains 1 electron which is moving, so it should have a kinetic energy. So that electron's kinetic energy is written here as minus h square del square by 2m. And then there is one more term which is representing the potential energy with respect to the potential energy of the electron with respect to the first proton and with respect to the second proton respectively. That is minus E squared by 4 pi epsilon 0 1 by R1 and minus E squared by 4 pi epsilon 0 into 1 by R2. They are the potential energy of the electron with respect to the first proton and second proton. So we have here only considered the electron's energy. We didn't consider the repulsion energy between the 2 protons. We didn't consider it. We will consider it later. Okay. So this is the total energy now, and the wave function is A into psi 0 R1 plus psi 0 R2. That is the trial wave function we have taken earlier. So the wave function contains a constant A, so that is why we have taken it outside in the left hand side. So here A into minus h square by 2m del square minus E square by 4 pi epsilon 0 into 1 by R1 plus 1 by R2 into psi 0 R1 plus psi 0 R2. So this is the eigenvalue equation without considering the proton-proton repulsion. Okay, only the electron's energy is considered here. Okay, now we know that by the last equation, you can see here in the normal hydrogen atoms eigenvalue equation, see here it is minus h square by 2m del square minus E square by 4 pi epsilon 0 R1 into psi 0 R1, which is E1 psi 0 R1. We are going to substitute it in this current equation, that is the first term minus h square by 2m del square into minus E square by 4 pi epsilon 0 1 by R1 psi 0 R1 will be E1 A psi 0 R1. A is a constant there, so we have to put that also. And the other one the same as minus h square by 2m del square minus E square by 4 pi epsilon 0 into 1 by R2 psi 0 R2, which is E1A psi0 R2. It is the same as for the hydrogen atom. So we can write substitute there like this. E1A psi0 R1 plus E1A psi0 R2. Now the remaining terms are A into E square by 4 pi epsilon 0 1 by R2 into psi 0 R1 and 1 by R1 into psi 0 R2, the opposite terms. So other terms we have taken already E1A psi 0 R1, E1A psi 0 R2. So the other terms are written there. So this one we need to find. So here E1A into psi 0 R1, E1A you can take out, E1A into psi 0 R1 plus psi 0 R2, which is A into psi 0 R1 plus psi 0 R2 is psi, isn't it? So E1 into psi you can write like that. Plus A E square by 4 pi epsilon 0. Why it became plus sign there? It should be minus there, isn't it? It should be minus. There is a mistake there. Should be minus. So A E square by minus A E square by 4 pi epsilon 0 into 1 by R2 into psi 0 R1 plus 1 by R1 into psi 0 R2. So now let us take, this is only H psi, isn't it? So let us now take the expectation value of H in the state psi. So psi H psi, inner product will be H expectation. Psi H psi will be the expectation value of H. So we are putting for psi it is psi 0 R1 plus psi 0 R2. So let us do that. So if you take psi, E1 psi is E1 itself, isn't it? So E1 itself we have written there, minus A modulus square. We have taken inner product. So A will come 2 times, isn't it? So the first term also A will be there, second term also there will be A. Bra will be having A, ket will be having 1A. So 2A will be there. So that is why modulus A square is coming out there. And E squared by 4 pi epsilon 0 is constant. And psi is psi 0 R1 plus psi 0 R2 into A. A has come out. So it is psi 0 R1 plus psi 0 R2. So psi 0 R1 plus psi 0 R2, 1 by R2 psi 0 R1. See that inner product? First term. So first term we have written the inner product. Second term also will have psi 0 R1 plus psi 0 R2, 1 by R1 psi 0 R2. Isn't it? Okay. So that is also the inner product which is coming as the second term. So equation 12 we have written. Now we are going to take this is actually integration. Integral if you substitute for psi 0 R1 and psi 0 R2, which is 1 by root of pi a cube e raised to minus R1 by a. There was a mathematical term for this psi 0 R1 and psi 0 R2. So if you are going to substitute that, you will be doing that integration, isn't it? So it will be an integral, isn't it? So this integral we are substituting as here, like d is equal to psi 0 R1 1 by R2 psi 0 R1. We are taking that psi 0 R1 1 by R2 psi 0 R1. So it is the first term. First term. See that psi 0 R1 1 by R2 psi 0 R1. Second term will be psi 0 R2 1 by R2 psi 0 R1. Isn't it? So there are 2 terms. You can split into 2 terms. The first term you can split into 2 terms. In that 2 terms, the first term we take as psi 0 R1 1 by R2 psi 0 R1. That is, we call it as D. And the second term also can be splitted into 2, which is psi 0 R1 1 by R1 psi 0 R2. Isn't it? And the other one psi 0 R2 1 by R1 psi 0 R2. So the first and bra and ket, if it comes same, we take it as D. Here psi 0 R1, first term psi 0 R1, the last bra and ket both are psi 0 R1. Okay. I will stop.